Welcome to the session on normal distribution. Normal distribution is a very important distribution with respect to continuous random variables. So, this distribution is having lots of applications in engineering as well as in management science. And particularly if I consider the topics like sampling and hypothesis testing, this is a very important distribution. Now, we will see the normal distribution in detail. So, one important thing we need to remember is this distribution is related to a continuous random variable. Suppose if x is a continuous random variable whose probability density function is defined by 1 by sigma root 2 pi e power minus of x minus mu whole square by 2 sigma square, where x takes all the values, that is minus infinity to infinity, then we say the random variable x which is continuous follows normal distribution. And suppose if we give or consider all the values of x and if we plot f of x, then we will see the curve which is a bell shaped curve, and it is called as normal curve. So, which is bell shaped, and where if we can see the x axis is like a asymptote to the curve, and which is symmetric, as we see symmetric about the mean, which we will see later. And this is this another name people uses for this distribution is in communication system they call this as Gaussian distribution, and this is called as Gaussian curve. Now, the point here is, as we have been doing, suppose if we want to find probability of x lying or x taking values between x1 and x1 like this. So, that is we want to find the probabilities of x taking values in interval x1 and x2. Then what we have to do is, like, because it is a continuous random variable, so we have to go for integral from x1 to x2 f of x dx. So, that is integral x1 and x2, and if f of x for this distribution is as given as mentioned here, 1 by sigma root 2 pi e power of minus x minus mu whole square by 2 sigma square dx. Right. So, then theoretically what we say is we have to evaluate this integral, then use the limits to get the probability that we are looking for. But here this integration e power minus of x minus mu whole square by 2 sigma square cannot be evaluated so simply like what we have been doing. So, then what we do is we will convert this into standard normal distribution. So, when we convert this into standard normal distribution, then we can use the normal distribution tables available to find out probabilities that we are looking for. So, that means here whenever we are dealing with normal distribution, then we have to convert this into standard normal distribution. How to convert this into standard normal distribution? By using the transformation, that is x minus mu by sigma equal to z. If we use this transformation, then this becomes an integral e power minus z square by 2 dz, which is evaluated, and for given set of values the normal distribution tables are prepared. So, simply what we have to do is we have to convert the given normal distribution problem into standard normal distribution, then we have to use the tables to find out the probabilities which we are looking for. Now, to understand the normal distribution process, now we will consider a simple example. Let x be a normal random variable where mu is given and sigma is given. Then we need to find the probability that x takes values between 4 and 5, and other one is where x takes a value greater than 5.5. Then how to do this? So, as discussed, like if it is a normal distribution, then it is very difficult for us to evaluate the integral, then we need to convert this into standard normal distribution by using x minus mu by sigma equal to, that means here if I consider this p of 4 less than x less than 5. Now, so when x equal to 4, we need to find what is the corresponding z value, that is z equal to x minus mu by sigma. that is x equal to 4 here, minus mu value already given in the problem 4.35, and sigma is given, that is 0.59. Right. Similarly, when x equal to 5, we have to find its corresponding z value, that is same way, x is 5 minus mu is 4.35 and its corresponding sigma is 0.59. So, here we will get its corresponding, that means what we are doing is we are converting normal distribution into standard normal distribution. Then once we had the normal distribution values, then we used tables to find the probabilities that we are looking for. Now it becomes, this problem becomes P of minus 0.59 less than z less than 1.10. Once we are into normal distribution, then very simple. So, this is f of upper limit, that is 1.10 minus f of minus 0.59. So, what is this f of 1.10 stands for? This is nothing but the tabulated value corresponding to 1.10. So, now what we have to do is we have to take the normal distribution tables where we will have z values here. In this case, we have to see where we will find 1.1, then here 0, 1, 2, 3 like this we will have the z values. Now, from the normal distribution tables, we have to find the probabilities corresponding to the z values. In this case 1.10. So, what is the value corresponding to this? Similarly, for f of minus 0.59 we have to find. Now, from the normal distribution tables, we find the value corresponding to 1.10 is 0.8643. Similarly, for f of minus 0.59 from tables it is 0.2776. Once these values are there, then we can plug in the values and we can solve the problem. Now, extending the discussion, like what is this 1.10 and 0.8643 stands for? Like here, the probability under the curve from minus infinity to 1.10 is 0.86. That means here 0.8643 is nothing but the area under the normal curve from minus infinity to the z value 1.10. This is. Similarly, the probability under the normal curve from minus infinity to minus 0.59 is 0.2776. Then by using the values we can find the corresponding probabilities. Here, if the normal distribution table values are not available for minus value, then we can use this relation, that is f of minus z equal to 1 minus f of z. So, whenever we want to find the values corresponding to minus z, we can use this relation. Now, coming to the second one, here same thing, like the probability that x takes the value greater than 5.5. Now, what to do? In the same way, we have to convert this into standard normal distribution. Then by using tables, we have to take f of z values. Now, if we take the second one, p of x greater than 5.5. Now, when x equal to 5.5, we will find the standard normal random variable value, that is z equal to x minus mu by sigma, where x is 5.5, mu is 4.35, 0.59. That is, now z value is 1.95. That means now what we need to find is p of z greater than 1.95. Right. Now, as we have been discussing, we will see the normal distribution tables. Then corresponding to 1.95, what we get, that is what we can say is f of 1.95, what we get from the tables is 0.9744. This is corresponding to 1.95. Now, what we want to find is p of z greater than 1.95. So, how to find it? Now, as discussed, now the value corresponding to 1.94 is minus 0.9744, means the area under the normal curve from minus infinity to that z value, that is 1.95, is this one. This total probability or area under the normal curve is 0.9744. But here what we need to find is probability where z greater than 1.94, that is z greater than 1.94 means this value, that is this is the probability or area we need to find. That is how to find. Now we know that total area under the normal curve is 1, that means total probability is 1, where till this 1.95 the value is 0.9744. Then if we take 1 minus f of z, we will get the probability we require. So here that is nothing but we can write this as 1 minus f of 1.95. So that is 1 minus 0.9744. So which results in 0.0256. So this is how we need to solve a problem related to normal distribution. So first what we have to do is we have to convert a normal distribution into random normal distribution, that is by using z equal to x minus mu by sigma. Then once we had the random normal variable values, then using the tables we have to find the values, and by using this we have to find the probabilities that we are looking for. Now we will take this example. Here if 20% of the memory chips are defective, then find the probabilities that out of 100 randomly chosen chips, and the first one is find the probability that at most 15 will be defective, and second one exactly 15 will be defective. Now here, so which distribution we have to find and how to use the distribution. Now first thing is here if I see it clearly, 20% of the random chips, that is here probability is given, this is p given, and the second one is n is given, that is 100. So where p equal to 0.2 and n equal to 100. So which distribution we have to choose? If I see here, it almost looks like a nearer to binomial distribution, where the probability of success, that is p, is constant and number of trials are finite here. Now what we do is by using the data which we assume that of binomial distribution, and what we do is we will apply the normal distribution, that is what we call as here we use binomial approximation of normal distribution. Now we assume that, or we take that this follows normal distribution. Right? In this case, now the first one if I take, the at most 15 will be defective. At most 15 will be defective means p of x less than 15. So less than or less than or equal to 15, that doesn't make any difference. Next what we have to do is we have to, as we have been discussing, whenever it is a normal distribution we have to convert it into standard normal distribution, that by using z equal to x minus mu by sigma. Right? Now here actually mu is not available and sigma is not available. Here what the data available is only the probability and the n. So what we do is, that's why here what we do is we use the binomial approximation of normal distribution. That is, we know if a random variable follows binomial distribution, then mu equal to np and sigma equal to, that is variance equal to npq. So here n is available, p is n equal to 100 and p is 20%. So by using this we can have mu as well as sigma which we require to convert normal distribution into standard normal distribution. Then we will get p of z less than minus 1.13, then which is nothing but f of minus 1.13, where from the normal distribution tables we can have the values required are corresponding to minus 1.13, where we get this probability. And second thing is exactly 15 will be defective. Exactly 15 will be defective. That is actually what we want to find here is p of x equal to 15. Right? And here we are going to use normal distribution. Right? So how to use, if we want to use normal distribution, then we require the upper bound as well as lower bound because it is in interval. So then what we do is this p of x equal to 15 is nothing but x takes values between 14.5 and 15.5. So p of x equal to 15 can be written as p of 14.5 to 15.5. Now the same way of doing the things, that is converting x in terms of z, that is converting normal random variable into standard normal random variable by using same kind of approach, x minus mu by sigma, where mu equal to np and sigma square equal to npq. So then we'll get probability of minus 1.13 less than z less than minus 1.13. Then the same way it is f of upper limit minus f of lower limit, and from the normal distribution tables we can have f values corresponding, right? As discussed here, if f of minus 1.38 is not available, then to find f of minus 1.38 we can make use of this relation, that is 1 minus f of, that is f of minus z equal to 1 minus f of z. So by using this we can find the probabilities or f of z values for even negative values, right? So then we'll get the required probabilities. So this is how we can solve problems related to normal distribution. One is, if the mu is given, sigma is given, then we can solve the problems where we have to convert normal distribution into standard normal distribution by using the transformation z equal to x minus mu by sigma. If mu and sigma are not available, then we use binomial approximation, that is we use mu equal to np and sigma square equal to npq. By using this we will find mu as well as sigma values, so that we can convert normal distribution into standard normal distribution, so that we can solve the problems. Now before closing normal distribution, just we will have a quick recap of what is this normal distribution. So one important point to recall is, normal distribution is a distribution related to continuous random variable, and second thing is the graph, or if you plot the probabilities of normal random variable by considering all values, will get a curve which is called as bell curve, which is a bell shaped curve, which is called as a normal curve or Gaussian curve. And third one is, whenever we want to solve a problem related to normal distribution, we have to convert it into standard normal distribution, and to solve a problem related to this, always we have to use normal distribution tables, without which we can't solve a problem on normal distribution. So this is an important distribution which we have been using in various topics like sampling distribution and testing of hypothesis, etc., etc. So with this we will end this session. Thank you.